Hey, Devin.
Hey,
How are you?
I'm doing good.
Good.
Yeah.
Uh, do you have the review in front of you?
Yes.
All right, cool. Um, I did kind of a difficult thing to us. I was and did I pull up the right review? Because I've done a couple reviews. Is this the same? This is the same one that I handed out, right?
Yes.
Okay, cool. I did kind of a cruel thing to us by adding the zeros of the function to the first two because it requires using the quadratic formula.
Yeah.
So, but we'll break it down and do the vertex and the axis of symmetry. And actually, for the test, since I noticed that, I went and fixed it, and I took finding the zeros off the graphing part.
Okay.
So that part won't be on the actual test, but to follow the directions for the review and just to clarify what the zeros of the function are, we'll
hmm
do it here. Plus, it'll give us a little extra practice on the quadratic formula, which never hurts either.
Yeah.
But to find the vertex, which I think you did this yesterday in class, didn't you?
I did some of it.
Yeah, I was going to say, I feel like I remember us talking about this. It's negative b over 2a to find, actually, the axis of symmetry is that part. So the negative b, or the opposite of b in this case, which is going to be the opposite of negative 4 all over 2 times a, which in this case is 2. So that's going to be 4 over 4, which equals 1. So our axis of symmetry is x equals 1. And now to find the other part of the vertex, the y-coordinate of the vertex, you just plug in the 1 that we got into the equation, and we got 2 times 1 squared minus 4 times 1 minus 2. So that's 2. 1 squared is 1. So that's 2 times 1 is 2. Minus 4 times 1 is 4 minus 2. So then that's negative 2 minus 2, which equals negative 4. So our vertex is 1, negative 4 for number 1.
Okay.
And actually, to find, sorry about that, I should have had this erased. To find the zeros of the function on this particular one, you can do a number of things.
hmm
Do you use Desmos ever?
No, I usually don't.
Okay. You can use Desmos. That's a good thing, and I can kind of show you that too while we're on here, just to kind of familiarize you with how you can find it an exact point on Desmos.
hmm
But we're going to work the quadratic formula to find the zeros of the function, which the zeros of the function, just to remind you again, is where the graph actually crosses the x-axis. And sometimes when we're doing those, you'll get no solution, and then that simply means that that particular parabola, or actually imaginary solution, that particular parabola never crosses the x-axis. We got 2x squared minus 4x. Minus 2, is that right? Is that
Yes, that's right.
okay?
Yes.
Okay, so then we have the opposite of b plus or minus the square root of negative 4 squared minus 4 times a, which is 2, times c, which is negative 2, all over 2 times a, which in this case is 2. Lots of 4s and 2s.
Yeah.
4 plus or minus negative 4 squared is 16 minus 4 times 2, which is negative 8 times negative 2 is positive 16 over 4, which that's going to be 32 over 4, which actually that is going to, I can simplify this radical to be 4 plus 4 times the square root of 2 all over 4. So all of this actually cancels. It becomes 1 plus or minus the square root of 2. And for our purposes here, you actually are going to find, you know how before I was like, okay, when you're using the quadratic formula on the quiz and you get an answer that looks like this, I'm fine with you leaving it like that. But when you're actually trying to graph something like this, you do need to find the square root of 2. Does that make sense?
Yes.
And the square root of 2, so that's going to be 1 plus or minus 1.41. So 1 plus the square that. So your zeros are going to be 2.41 or negative 0.41.
Yeah.
So those are going to be fun to graph. Roughly 2.5, I'd say, and a half. Right there. And then right there. And that gives you your points. How'd you do on that one?
Well, when I was doing it, I looked in the book and it said just like to pick 2 points, but then I had remembered that part. So I got the vertex and the axis of symmetry, but I didn't get like the points.
Okay, well that's perfect. If you got those, that's going to be what I'm really focusing on the test. Yeah. I just was kind of hoping we'd have prettier answers for the zeros of the function, but CUDA software doesn't always cooperate with me.
Yeah.
But that's awesome that you looked in the book and to just try and figure out some points. That would have been fine too, just to kind of, because it takes 3 points to graph a parabola. So that's great that you knew to do that and look that up. I'm really proud of you. That's awesome. And like I say, the vertex and the axis of symmetry is going to be where the focus is going to be on these 2 particular ones. So if you get those, you're 95% there, and just sketch that graph. So did you do number 2?
Yes, I did it.
Okay, so we got negative b, which is going to be the opposite of 16, or negative 16, all over 2 times a, which that's going to be 2 times 2, which is 4. So then that reduces to negative 4. So our axis of symmetry is x equals negative 4. Is that what you got also?
Yes.
Cool. Awesome. And then to find your vertex, you're going to plug in that negative 4 into the equation. So you'll have 2 times negative 4 squared plus 16 times negative 4 plus 31. So negative 4 squared is 16 times 2 is 32 plus 16 times negative 4 is going to be a negative 64. Is that what you got? Plus 31. So negative 32 plus 31 gives you a negative 1. Is that what you got?
Yes.
Cool. Makes me feel better when somebody else gets the same answer as me.
Okay.
All right. So we've got our vertex and our axis of symmetry. And now just as, once again, just a little extra practice on the quadratic formula.
Mm-hmm.
Hold on, Devin. Sorry, you need something?
Did you print anything?
No, I haven't printed.
Like, did you hit the print button for printing in yours? So it's going to be intertwined with all my stuff I just printed.
I might have printed one thing, but it would only be one piece of paper. It wasn't much because I knew you had a lot going to the printer.
Do you hear my print just now?
No,
No. Thank you.
hold on just a second.
Oh,
It's plugged in. Sorry, Devin.
It's okay.
As soon as I get this erased, would you mind, Devin, telling me what the problem is?
No, I can do it.
Okay, thank you.
You're
Let me
welcome.
get this erased. Does working with the quadratic formula help a little bit to have some extra review on it?
Yes. Yeah.
Yeah, I was going to say that was the only good thing about the fact that the answers weren't real pretty
Yeah.
for the graphing part, is it did give us some extra, practice on the quadratic formula, which never hurts because it has so many moving pieces and parts that it's got a lot of places that errors can happen. What is the equation?
It's 2x squared plus 16x plus 31.
Okay, can you see it okay?
Yes. Mm-hmm.
Okay, cool. All right, the opposite of b, which is the opposite of 16, plus or minus, and then the square root of 16 squared minus 4 times a, which is 2 in this case, times 31, all over 2 times 2. So we've got the opposite of 16, plus or minus. 16 squared is 286 or 296?
256.
Oh, 256. I was way off. 256 minus. And then 8 times 31 is 248. Is that what you got?
I think so.
And then negative 16 plus. And then 256 minus 248 is 8. All over 4. Which then that reduces to negative 16. And that's going to be 2 times the square root of 2 all over 4. Oh, this is going to be a fun one. Negative 8. Oops, didn't mean to do that. So I've got negative 8 plus or minus 2 times the square root of 2. Putting that into the calculator. And I got 10. Actually, nope, because I didn't get my negative in there. Negative 5.17. And what'd you... Negative 8 minus 2 times square root of 2. Negative 10.17 0.83. Roughly.
Yeah.
I messed up. This should have been a 4. Oh, I messed up totally. Did you see where I messed up?
No.
Okay. Back here, let me erase this. I'm moving too quick. Back here, where I wrote negative 16 plus or minus 2 times the square root of 2 all over 4. Divide everything by 2. 8. And that turns out to be 1. Then it's negative 8 plus or minus the square root of 2. Sorry about that.
It's okay.
And then I think, hang on just 1 second. I'm going to double check myself. Since I'm obviously struggling with the simple math today.
Yeah.
2x squared. 2x squared plus okay, see on Desmos where it says negative 3.293 and then negative
Yes.
4.707. Those are our goals for getting those.
Okay.
So that's where it crosses the x-axis. So I'm going to try her one more time.
Okay.
Eight. Ugh. I did it. I got it. So this, when you use the minus, is the 4. This is the negative 4.7. And when you use the, what did I say that was? Yep. I got the same thing. Yay, finally. And then that was with the minus. And then I've got negative 8 plus the square root of 2. gives me the 3 point. I have 3.3. What did it have? 3.2. Yep. That's what I have actually. 3.293 on my calculator. So yay. This was it. I'm going to round it to 3.3 and go back to my graph. 4.7. Such a lovely thing to graph. And 3 point. So that definitely took a minute. So did you just use a T-chart for that one as well?
Yes, I just used that.
Okay. All right. Okay. A little more tedious for that, but since I put it on the directions, I thought I better do it. But the T-chart would work fine for sketching the graph and probably would be a lot easier. But like I say, I'm going to focus predominantly on the axis of symmetry and the vertex.
Yeah.
For the test. All right. So to solve each equation by factoring, and one of the key things, and you did not do this, but just some of the things that were happening yesterday on the quiz that I noticed is going to be important for factoring and completing the square and the quadratic formula is to make sure that the equation is in standard form before you begin doing anything.
Yep.
So on this particular one, p squared plus 7p, and then you would add 12 to both sides so that you can get a 0 on this other side. Does that make sense?
Yes.
Okay. So what two factors, when multiplied together, give you 12, that when you add them, give you 7?
3 and 4.
Perfect. So p plus 3, p plus 4 equals 0. And then when it means solve, once again, you're looking for the roots or the zeros or where it crosses the x-axis. So you take these two little tiny algebra problems, if you will, and you set each one or each little factor equal to 0 individually and solve for p. So that's going to be p plus 3 equals 0 and p plus 4 equals 0. So p equals -3 or p equals -4. Are those pretty easy for you?
Yes.
Yeah, I was going to say, I don't think you struggle with these really. So the answers are -3, -4. And so then the next one, in order to get it in standard form, you're going to add 4 to both sides. So you would end with k squared minus 5k plus 4 equals 0 in order to get that by itself. And what two factors, when multiplied together, give you a positive 4, but when you add them, give you a -5?
Oh, man. Oh, -4 and -1?
Yes. Perfect. And so then you take each of the little algebra problems or factors and set them equal to 0 and solve for k. So you've got k equals 4. And then with the other one, you've got k minus 0. And then so k equals 1.
Yep.
Okay, solve each of the equations by taking square roots. Once again, solving means finding where they cross the x-axis and remembering that there's going to be probably 2 answers when it comes to a quadratic. So the first thing you want to do is isolate the b squared variable all by itself. And in order to do that, you want to divide both sides by 100. And that leaves you with b squared equals 1. You take the square root of both sides. So b equals plus or minus 1.
Mm-hmm.
And that this plus or minus part is very, very important.
Yeah.
On this one, you divide both sides by 36. So now you have b squared equals 1 over 36. You take the square root of each side. When you take the square root of a fraction, you're actually taking the square root of the numerator over the square root of the denominator, which that equals plus or minus 1 over 6. On number 7, to isolate the v squared variable, you're going to divide both sides by 100. And now you have v squared equals the square root of 9 over the square root of 100.
Mm-hmm.
And when you take, well, actually, you have 9 over 100. When you take the square root of v squared, you have the square root of 9 over the square root of 100, which gives you plus or minus 3 over 10. On number 8, you're going to add 4 to both sides to isolate your x squared variable. And now you have x squared equals 25. And to get x by itself, you have to take the square root of both sides. So you have x equals plus or minus 5. Any questions about those?
No, I'm good.
Okay. All right, for 9 and 10, to isolate the squared variable, you're going to divide both sides by 64. And now we're left with x squared equals 49 over 64. We're going to take the square root of both sides. So that leaves us x equals plus or minus 7 over 8. With number 10, we're going to divide both sides by 81 to get the x squared variable all by itself. And now we have 100 over 81. Take the square root of both sides. And you have x equals plus or minus 10 over 9.
Mm-hmm.
How we doing?
I'm doing good.
Good. All right. So find the value of c that completes the square. So we're going to half it, square it, and then add it.
Mm-hmm.
So half of 7. And with these, when the number is odd, all I want you to do is write 7 over 2.
Mm-hmm.
And then square that. Square the numerator, square the denominator. So you've got 49 over 4. Take half of negative 16. So that's negative 8. Squared equals 64. Half of negative 6 is negative 3. Squared equals 9. Half of 9 over 9 would be expressed like 9 over 2. So that's going to be 81 over 4. Any questions about those?
No, I'm good.
Okay. All right. Now, completing the square. Excuse me. On these, I'm actually think I'm going to move this to that blank sheet of paper. So I may ask you to read me the equation if you don't mind.
Okay.
On these, the key thing, you know how on the quadratic formula and factoring, we're talking about getting it in standard form.
Yes.
On these, to complete the square, You know how we halved it, squared it, added it to find what value of C worked?
Yes.
Well, you're going to notice on these, there's something in the way or in that particular space where the C value would go. So what we want to do is create the space to make up that C value. Okay, can you read me the equation?
Yes. N squared minus 8n. It's minus 8.
Oh, sorry.
Okay.
Okay.
Plus 21 equals 6.
Okay, so what we want to do is create a space so we can come up with that C value. And this right here is in our way. So we want to subtract that from both sides.
Okay.
We want to make a space to create our C value. So negative 21 plus 6 is going to leave us a negative 15. So now I have n squared minus 8n. But I've created that space where I can add it. So now all I have to do is half it, square it, and then I can add it there. What is half of negative 8?
Yes.
Negative 4. And negative 4 squared is what?
16.
16. And whatever I do to one side of an equation, I have to do to the other.
Yes.
So you'll notice right here, I went ahead and wrote this in a factored form.
Yeah.
Okay. And it includes right here what I said was my half of this part. But if you'll also notice this n minus 4, I squared it. And the reason why I did that, if you actually squared n minus 4, like that, these binomials, you would actually get this trinomial right there. Does that make sense to you?
Yes.
Okay, good. So now what I have left is what I have done, or what we have done, is created a perfect square. And what we're going to do from here is take the square root of each side, which is going to leave us with n minus 4 equals plus or minus 1. And now we're going to add 4 to both sides to find our two answers. Because typically with a quadratic equation, you're going to have two answers because there's going to be two places that parabola is going to cross the x-axis. So now we have 1 plus 4, which is 5, or we have n equals a negative 1 plus 4, which is going to be 3. So those are our two answers. Does that make sense to you?
Yes.
Okay, good. Does that help?
Yes, it does.
Clear up any, because I know there might be some areas of cloudedness, because there's a lot of steps to these, a lot of moving parts, just like in the quadratic equation. So just working through a few of them definitely helps, make it a little more concrete as to what the steps are.
Yes.
Because this is definitely a multi-step process here.
Yeah.
Okay, the next one is did I get it? Nope, didn't get everything erased.
Like Greek to me.
Equals 5. Make sure I copy it down right. Does that look right to you?
Yes.
All right. So once again, to complete this square, hang on just 1 second. To complete the square, oh, Madison came and left. Sorry about that. You want to create the space.
Yes.
So I'm going to add 91 to both sides. It's going to give me 96 over here. And I've made space to complete that square. So half of -4 is -2. And -2 squared is a +4.
Yes.
And I'm going to add 4 to both sides because whatever I do to one side, I have to do to the other. And now I'm going to take the square root of each side. And that's going to leave me m minus 2 equals plus or minus 10. And then I'm going to add 2 to both sides to get both of my answers. So I've got 10 plus 2 is 12. Or I've got -10 plus 2, which is going to give me a -8. So this quadratic equation crosses the x-axis at 12 and 8.
So for these ones, do you just want like where it crosses the x-axis?
That's exactly what you're solving for in all of these.
Okay.
So you're looking at, so I'm looking for 2 answers, that 12 and -8.
Okay.
Because where it crosses the x-axis, the zeros, the roots, and the solutions to a quadratic equation are all exactly the same thing. It's just a different expression of the same thing.
Yes.
So that's really what you're looking for right there. All right. So for number 17, 18, 19, and 20, you'll notice that I did the same thing that I did on the quiz, where I identified the A, B, and C. And before you identify the A, B, and C, you have to get it to standard form.
Okay.
So the number 17 is not in standard form quite yet. We need to subtract 136 from both sides. So you have that. So A would be 3. B would be 7. And C would be 136. So now we'll plug in our values to the quadratic formula. And we've got the opposite of B plus or minus the square root of 7 squared minus 4 times 3 times -136 all over 2 times 3. So now we have -7 plus or minus 49 minus, or it could be plus. I don't know. Let's see what we turn out to be. 4 times 3 times 136. And I got 2 negatives in there. So that's going to be a positive 1632 all over 6. So -7 plus or minus square root of 1681 all over 6. I'm just going to, first thing I always do, Devin, is check, especially when it's really big like that, to see if it's a square root. Oh, and it is.
Yeah.
It's the square root of 41 is the square root of that. So 7 plus or minus 41 over 6. So now I've got -7 minus 41, which is -48,
Mm-hmm.
all over 6, which reduces to -8.
Mm-hmm.
And then -7 plus 41, which is 34 over 6. Did you get that also?
Yes, I got that.
So that reduces to 17 over 3. So I got -8 and 17 over 3. What'd you get?
-8 and 17 over 3.
What number was that? 17?
Yes.
17 over 3 and -8.
Mm-hmm.
Okay, cool. When you work that hard, isn't it nice to know that you got the right answer?
Yes.
That's a long equation.
Yep.
Good job. I'm so proud of you. Had you worked the whole review, or are you working with me?
I'm just working with you. Yesterday I got 1 through 4 done.
Okay. All right, cool. Well, that's fine that you're working with me. It was due today anyway, and it's a good place to do that. That's the whole point of Math Lab, actually.
Mm-hmm.
Okay, so that was 17. Now we're on 18. Did you get everything written down? Okay, before I
Yes,
erased
I got it.
I should have asked. I'm sorry.
It's okay. I got it.
Okay. All right. So now, this one's not in standard form either. So I'm just going to ask you on the quiz or test, would you be more likely to bring the 5x squared over to the other side, or the other two over with the 5x?
I'd be more likely to bring the 5x.
Okay. So I'm going to subtract 5x. Actually, let me do this up here. I'm going to say -5x squared then. And then I'm going to rearrange my 4x because it's the b term and needs to be in the middle. Plus 12 equals 0. So that now is in standard form, so I can identify my A, B, and C. So A is -5, B is 4, and C is 12.
Mm-hmm.
So all we have to do at this point then is plug in our values into the quadratic formula. So we have the opposite of B, which is 4, plus or minus the square root of -4 squared minus 4 times A, which is -5, times C, which is 12.
Mm-hmm.
All over 2 times A, which is -5. So we've got -4 plus or minus 16. And we got -4 times -5, which is a positive 20. And 20 times 12, that's going to be 240. All over -10. So now I have -4 plus or minus the square root of 256. We had that earlier too, didn't we?
Yeah. I think number 18.
So I feel like, what is that, 16 or 14 squared? I should know that.
16. Yep.
Okay. So -4 plus or minus 16 over -10. So -4 minus 16 is negative. Whoops. My stylus is going a little crazy. Equals -20 over -10.
Mm-hmm.
which reduces to 2. And then we have negative 4 plus 16, which gives us a positive 12 over a negative 10, which reduces to 6 over negative 5. So our answers are 2 and negative 6/5. So far, so good.
Yep.
Any questions?
I'm good.
Okay. Hang on just a second, okay?
Okay.
Hey, Bill, can you close your door? Hey, Bill, can you close your door?
Do you have a cup or? Do I need to get your cup?
Oh, I thought I muted it. I just screamed in your ear. I'm really sorry, Devin.
It's okay.
My husband was working, and I was like, oh my gosh, that's so loud. I thought I muted it before I started straight in your ear. Okay, and then on top of that, the Cami program locked up, and I could no longer erase. So I've got to reload the chapter review. Ugh. Yay. Okay, here we go. Try this again. No, it locked up again. Come on. Why? Why does it do this?
So you're wondering the theater table's there. You can bring back downstairs. Like that one.
Oh my.
And I never knew you had.
I'm so sorry, Devin. Let me see if it works over on the blank screen, and then maybe you could just read me the problem.
Yeah.
This one seems to be working a little better, so maybe I'll just have you read me the problem as is. I'm like, I hate to get this far and then we can't finish, you know? I'm like, please, Lord Jesus. Okay, and then let me ask you a question.
Okay.
Would you want to do another review tomorrow in class? Like to go over a few more problems?
Yeah, that's fine.
Okay.
Hello.
Hello.
Hey, it's Stephanie. How are you?
Okay, how are you?
I'm good. Just wanted to say a quick hello.
Oh, I appreciate it. Are you guys doing good at your house today?
We are. Brady and I got some time together today, which was nice. We got to go on a date after his orthodontist appointment, so that was kind of nice.
Oh, nice.
Yeah.
That's cool.
That's Brady's or Devin's teacher. That's Miss Sparks. Can you say hi?
Hey.
Hi. Say hi. She's being shy.
Well, that happens.
All right. Well, thanks. Have a good afternoon.
Oh, you too. Nice talking to you.
You too. Right.
Take care.
You too.
Oh no.
Okay. Do you want to read me the problem?
Yes, I'll read you the problem.
Okay.
It's 2n squared
2n squared
minus 14
minus 14
equals negative 12n.
Okay. All right. So in order to get it in standard form, we're going to move the 12 over to the other side by adding 12 to each side. So then we'll have 2n squared plus 12n minus 14 equals 0. So our A would be 2, our B would be 12, and our C would be negative 14. So now that we've identified all of our variables, we'll just plug those values in. We've got opposite of B, plus or minus 12 squared minus 4 times A, which is 2, times C, negative 14. All over 2 times A, which in this case is 2. So negative 12 plus 12 squared is 144. Then you have a 4 times 2 times a negative 14, which is a negative 112, but it's a minus, so that's going to make it a minus negative 112, which would make it plus 112, all over 4. So that's going to become negative 12 plus or minus 144 plus 112, which is 256. Oh, wow. What a beautiful thing. 3 times. Okay, so we have negative 12 plus or minus 16, because the square root of 256, as you and I well know now, is 16. So we got negative 12 plus 16, which gives us 4 over 4, which reduces to 1. Or we have negative 12 minus 16, which is a negative 28 over 4, which equals negative 7. So your answers are 1 and negative 7. So this parabola would cross the x-axis at 1 and negative 7. One more, right?
Yep, last one, number 20.
Takes a minute to get all this erased, that's for sure.
Yes.
Okay, what's the last one?
X squared plus 22 equals 11x.
Oops. So in order to get it in standard form, I'm going to subtract the 11x from both sides.
Yep.
And that's going to give me x squared minus 11x plus 22 equals 0. So my A is 1. My B is negative 11. And my C is 22. So now that I've identified all of my variables, I'm going to go ahead and plug it into the quadratic equation. So which I have the opposite of B, which is the opposite of negative 11 plus or minus B squared, which is negative 11 squared, minus 4 times A, which is 1, times 22.
Yep.
All over 2 times 1. So I've got 11 plus 11 squared is 121 And then 4 times 1 is 4, times 22 is 88. So 121 minus 88 is 33.
Yes.
So that's our answer. Because 33 can't be reduced anymore. So it's 11 plus or minus the square root of 33 over 2. The only practice we really didn't have on this particular review is reducing radicals.
Yeah.
Did you want to do a couple of those, or do you want me to give you some of those in class tomorrow and you and I work on them, or what do you want to do?
I mean, could we do 1 or 2?
Oh, absolutely. I don't mind at all.
Okay.
I'm just going to have to make some up in my head.
Yeah.
We're just going to reduce the radical part. Is that okay with you?
Yep, that's cool.
Okay. And hopefully the ones I'm making up really do work.
Yeah.
Okay, I'm gonna say that we get 168 as a radical. So we're gonna factor it. Do you use the factor tree or birthday cake?
I usually just use the birthday cake.
My favorite.
Yeah.
So we get 84 down to 42 to 21, and there's only one perfect square in it. Does that make sense? Because basically what you're looking for is pairs.
Yeah, 2s.
So I'm going to pull the 2 out, and then technically what I have left is this 42.
Yes.
Because I can't pull any more factors out. So basically the 2 that are left, this 2 and 21, you really want to keep those multiplied and under the radical, or just put that 42. So that's the reduction of that one. All right, one other thing that I want to show you. Let's just pretend for a second that we got a 4 plus or minus 2 times the square root of 42 all over 2. And it looked like that. You know, your final answer in the quadratic formula ended up looking like that.
Yes.
You can reduce this 2 to be 1, and that would be 2, and this would be 1. So your final answer would look like this: 2 plus or minus the square root of 42.
Yep.
You can't reduce inside the radical. You can only reduce the whole number outside the radical. But it can be reduced. Does that make sense to you?
Yes, ma'am.
Okay, good. All right, let's do one more. Let's do 284. Well, that's all the further it goes. I didn't know I would have one that ended so abruptly. So that's going to be 2 times the square root of 71. Let me think of another good one. Let's try 720. gives us 2. So that's 3. Is that 365? No, 360. One, 8. This one's going to go a minute. Okay. So let's look at all the perfect squares that we have. We have a 2, another 2, and a 3.
Yeah.
So it would be 2 times 2, which is 4, times 3, which is 12. And then you just put that 5 in there, inside the radical. Does that make sense?
Yes.
So if I double check that, 12 squared is 144 times 5 is 720.
Yep.
So does that kind of help clarify that?
Yes, ma'am.
Okay. Do you want to do any more, or do you feel better about that even?
I feel better. I was just wondering, maybe like, cause I had kind of a bit of trouble on the first quiz we took. So, if we could go over like some of the questions on the first review for the quiz.
Oh yeah. So for quiz number 1 and the first review.
Yes.
All right, give me just a second. Let me pull that up. And let's pray that it's in my drive. Was it this one?
Yes, I think so. Yes.
You know what I feel like? Oops, my bad. What I kind of feel like happened to you on this, and I don't feel like it'll happen now, is I feel like when it used the word solve at that time, I feel like a lot of the students weren't completely clear on that solve means to find the x-intercepts.
Yeah.
And a lot of people were thinking, oh, I'm going to look for the vertex, which you really needed to, wow, Cammie's running really slow. Sorry about that. Where you just needed to find where it crossed the x-axis. I don't think you're going to struggle with that, because as long as it asks for the vertex, wow, please come up. On this one, I feel like it won't be that bad, because when it says find the axis of symmetry, which is kind of what we did on the first couple of problems.
Yes.
That's all you're going to need to do. And then the zeros of the function are going to be where it crosses the x-axis. Cammie's working so poorly today that I just feel like what I might have to do is actually make sure I have this in class tomorrow, because
yeah, because I think a lot of people just like plug the thing into their calculator, and it like gave them the graph, so then they just got they didn't get like the whole thing.
Right.
Because that's what I did for a few of them, and I know I didn't do so well on that one.
Yeah. Well, I think really what it is knowing, like on number 3 and number 4, to sketch the graph and to sketch the graph and find the zeros of the function. That's going to be exactly where it crosses the x-axis. So a couple things that I can tell you, like on number 3, since I can't really write well, but if you'll look at number 3 on the review there, I know that I can factor that one.
Yes.
Because there are 2 factors that add up
Yes.
to be 6. So that's going to be where it's going to cross the x-axis. So that one's pretty easy. Now, number 4 is not quite as easy. You know, but you could put it in your graphing calculator and do that trace thing and all of that.
Yeah.
But I'm not going to make those, you know, quite as bad.
Yes.
They'll be the test is going to be a lot more like what the review is. So going through the review and just knowing how to find the vertex and the axis of symmetry, you should be good. Like for number and there, I'm not even going to have you compare it to the parent graph.
Yeah.
Either. So, but this is where you struggle the most.
Yeah, I think so. I think because
5 and 6.
Yeah.
Okay.
Yeah, because I understood the part like the axis of symmetry and the vertex, but then when I didn't get where it crossed the x-axis, that was kind of where I struggled.
Okay. All right. Well, where it crosses the x-axis are going to be its factors, which now what you could do if you were given the same thing now, you've got 3 ways to do it. You could factor it, you could complete the square, or you could do the quadratic function to find where it crosses the x-axis. Does that make sense?
Yeah. So like on the one, the ones that we did on the chapter 9 review. So like when we did the quadratic equation one, you wouldn't put the axis of symmetry. You would put like the other one.
Yes, you just put your A, B, and C in to solve for where it crossed. But
right, okay, now I got because
the quadratic formula gives you the zeros of the function or where it crosses the x-axis.
Yeah, so like number 3, A would be 1, and then B would be 6, and C would be 8.
Yes, sir.
Okay.
Perfect.
Yeah.
So that's what you would use to find the zeros of the function.
Yeah.
And in order to find the vertex of the function, which is a little bit more what you do to find the vertex, you just use the negative B
over 2A. Yeah.
Over 2A. And then that gives you the axis of symmetry, and then you use that particular value, plug it back into the equation to find the y, and that gives you the coordinate.
Yep.
So, but the chapter, it's going to be more like the chapter 9. Of course, my Cammy's locked up again, so I can't even show you anything.
Yeah.
But I'm glad that you came back and asked that. Does that kind of clarify what the zeros of the function are?
Yes.
Okay, so it's the roots, the zeros, where it crosses the x-axis, and you can use when it doesn't say, oh, solve by completing the square or solve by using the quadratic formula. It doesn't give you a specific way to do it. You can use any of the methods that you've been shown. You can factor if it looks like it's factorable. Number 3 is factorable. Number 5 is factorable, and number 6 are factorable. The only one here, if you were asked to do the zeros of the function that you would have to use the quadratic formula on, is going to be number 4.
And the factoring is like the one where you find 2 numbers that multiply to equal it, and then the 2 numbers also add up to equal another number.
Right. So you would find 2 numbers that multiply together to give you the C value, which when added give you the B value. So like for number 3, the 2 factors that multiply together to give you 8, that when you add them give you 6. So 4 and 2 multiply to give you 8, but when you add them, they give you 6.
Yes.
And on number 5, if I take a -5 and a -3 and I multiply them, I get a +15. But when I add them, I get a -8. So it would cross the x-axis, and then you actually set it equal to 0. So it's going to cross the x-axis at 5 and 3. Does that make sense?
Yes, ma'am.
Okay. And the same for number 6. So now you actually, at the end of the chapter, you have more ways to actually do number 3, 4, 5, and 6, whereas you were kind of limited there.
Yeah.
And I think next year I learned a valuable lesson even for myself. I will quiz at the end of 9.1 and 9.2 so that nobody gets mixed up, because that was really confusing, I think, for a few people, the zeros in the vertex.
Yeah.
You were not alone, Mr. Reardon. So, but I feel like everybody has a better handle on it now.
Yes.
But we can definitely go over some more of that tomorrow in class too. So we'll have another review in class, and then y'all will be able to work on that over the weekend too.
Okay.
Okay.
All right.
Any other questions?
I'm good.
Okay. Thank you so much for coming to Math Lab.
You're welcome. Thank you for doing it.
No problem. Have a good afternoon.
You too.
All right. Bye-bye.
Bye.